Okay, this process again. Here's the process. This is another cartoon that I stole, but you see how sort of when we one step up. Let me back up just a second to show you one step up from this sort of stovetop action is this sort of a Mashin apparatus, and we in which we have three vessels, one, two, three, and here obviously in the middle vessel, this is showing you the sparge step. But let's back up a second and say, well, we're going to heat our grain in hot water here, and then we're going to be able to pump that liquid out into another container, and then we have over here we have on the left side we have a container of warm water ready to go that will allow us to sparge. After we lauter, we are ready to sparge that grain, and again maximize the amount of maximize the amount of sugar that we can get in our wort. So that's the basic process. Mash in, lauter, sparge. Now there's our sweet wort. And ideally, we got all this controlled by pumps and temperature control, et cetera, et cetera. That's our process. All right, now there's more to controlling the characteristics of your beer than simply changing the temperature of the mash in. It's much more complex than that. Here's one way that we can get started thinking about it: roasting the malt. So I talked about during the malt phase, we have to warm the grain and let it begin to germinate, and then we dry it out. But then there's other processes that can happen as well, and this is roasting. So here's kilning. This is the end of our malt process where we dry things out. We can roast to different extents before or after kilning, and you can imagine that if you roast beforehand, then you're going to be denaturing some of those enzymes, and that can affect the ability of that malt to then go on and generate fermentable sugar. So that's what the point of this little bullet is. Often this roasting can denature the amylases. So heavily roasted malts are going to be useful for flavors, but not for conversion during mash-in. On the left here's another photograph that I swiped. At least I cited this one. And you can see the range of colors that you can achieve by different kinds of roasting of the malts. What else to say about this? So again, what we're working for here is the maintenance of complicated sugars that add to flavor and add to texture, and also various kinds of processes giving rise to these different colored compounds. And we've talked already about Browning reactions and Maillard reactions, but that's part of what's in play here. Two other things to mention here. Crystal malts, these undergo extraction before roasting. So this is a way of circumventing the problem of denaturing those amylases. We extract the carbohydrates, then we roast. And then if you ever order any of these crystal malts, you'll see that they actually are coated in sugar crystals. So those sugars are now ready for fermentation. Another step is extracting the carbohydrates from the malt, and then this is something that's going to be used. Well, it's used by lots of brewers, but certainly common amongst homebrew beginners, where you don't want to worry about using whole grain recipes. You can buy extracts of the malt, and in that case, you're controlling the color and sugar very, very to a very, very fine degree. I'm not talking in detail about any of these different kinds of malts, but I have referenced here one of the nice wikis that exist for homebrewers if you want to read more about the different malts that are available. I want to talk briefly about categories of beer. Let's see. Let's break them into two big categories: ales and lagers. And you'll see that I included a third category here, the lambics. These are sour beers. We'll talk very briefly only about them. And again, this is not an exhaustive list, but it gives you the general sense of the varieties of beer, of ales and lagers that are available. I'll talk about the differences that go into ales and lagers as we proceed, but let's first just run down the ales. And so we have a pale ale, in which, again, we might not be using roasted malts at all in this case, and we have a alcohol by volume concentration of about 5%, so low on the color evolution, relatively high on the conversion and ethanol concentration, perhaps. Then we have a version of the pale ale that's referred to as the India Pale Ale. This is a pale ale that's very heavy on the hop especially in modern times. Very heavy on the hop flavors. This is popularized as an English export in the 19th century. There's a lot of lore surrounding the development of the India Pale Ale. Especially popular story is the idea that the hops were added as a way to preserve the beer as it was shipped around the globe to India from England. I think that tale has been, I won't say debunked, but the story is a little bit more complicated than that now. Suffice it to say that the India Pale Ale became very popular in the 19th century and has only increased in popularity, especially recently in the last decade or so. So, a pale ale, but very heavily hopped. Brown ale, using those roasted malts. Again, roasted malts, giving us a color, brown, and then perhaps a lower alcohol by volume. Now, this could be controlled by a number of different processes, not necessarily because we're using roasted malts with less active amylases, but that's certainly one possibility. The porters are similar to brown ales, except that they use something called patent malt, or if you're on the other side of the pond, we'll refer to these as patent malts. These are very dark malts. They're black, literally, because they've been kilned at such high temperatures. So it imparts a very heavy body, a full body, as well as a very dark color. The other interesting thing about these is that they were the first beers in the 19th century in England to be aged at the brewery instead of at the point of destination. We'll elaborate on the porters with the stouts, which are porters that are fermented to a higher ethanol concentration than the porters themselves. And then jumping back across the pond, the American pale ales, very similar to the British pale ale, except that they're characterized by their use of hops that were hybridized in the United States. All right, and finally, there's the wheat beers, or in Germany we would say the Weizens, and these are beers that are made in part with wheat instead of barley, at least in part, with some wheat. All of these ales are to be distinguished from the lagers in terms of as we'll see, the temperature at which they were fermented. This gives rise to some interesting characteristics, as we'll see, and I'm not going to delve into these very deeply, but just simply suffice it to say that the lightest in terms of color and alcohol concentration are the Pilsners, and then the Bocks have a slightly higher concentration, and then the Doppelbocks have the highest concentrations of ethanol of these lagers. Stout sour beers is our last category, and I'm really not going to pay them nearly enough attention. Just suffice it to say that these are characterized by occasionally the use of wild fermenters. That is, whatever bugs happen to get into the fermentation. And these, of course, is going to include some bacteria that are lactic acid producers. This, of course, is where our sour flavor comes in. Let's talk very briefly about beer color, as long as we're thinking about the different characteristics of beer. There's a few different beer color references. The one that's probably the most familiar is the Lovibond scale, named after a British brewer, or son, I guess, of a British brewer in the 19th century. But it's very similar to now what's referred to as the standard reference model. Effectively, all of these models simply measure the amount of color. In the original Lovibond colorimeters, they were just using a set of slides that had defined color features. Now, the standard reference model uses the absorbance at a particular wavelength of light. This is pretty down into the bluish, and so if we're absorbing strongly in the blue, then we're not absorbing strongly in the yellow and darker reddish brownishes. So in any case, they amount to the same thing, and regardless of which scale you're using, here's a European scale, here's the Lovibond scale and standard reference model scale. The larger the number, the darker the beer, and we see that the pale lagers have the lowest rating and the lightest color, all the way down to the porters and stouts, which have very dark colors. I'm showing you this slide. This is a photograph I took of a brewery in Mexico City. As you can see here, there's the Lovibond scale, and their specialties were beers brewed with adjuncts Those are other stuff that is going to provide starch or carbohydrates for fermentation. In this case, it was mostly, you could guess what they were, mostly going to be agaves.